Good afternoon, students. Let me start the new topic of the unit 1, that is what? Function. This unit has two topics. One is the relation that we have done already, and the second topic is here the function. Now here, what is the meaning of function? Let me tell you. The concept of a function is a special type of relation. A relation may relate each element of the domain to more than one element of the range or the codomain. But a function relates each element of the domain to one and only one element of the codomain. What it means? Now here let me repeat it again. The concept of a function is a special type of relation. Number one. A relation may relate each element of the domain to more than one element of the range or the codomain. But a function relates each element of the domain to one and only one element of the codomain. Or it can also be defined like this. Let x and y be two non-empty sets. A function or a mapping f from x to y, written as f from x to y. We always write the function like this. F is a function from x to y, is a rule by which each element x belonging to capital X means set is associated to a unique element of y belonging to y. It means it is a mapping, or it is function is a mapping. It is just a rule by which each element of x is associated or related with a unique element of y. This type of mapping is known as what? Function. Now here, element y belonging to y to which x belonging to x is related is called the f image or image of x under f, or value of the function at x, and x is called the pre-image of y. Now if f is a function from x to y, then the element of x are known as the pre-image of the element of y, and element of y are known as the images of the element of x. Now here the set x is called domain. If f is a function from x to y, then the set x is known as domain and set y is known as codomain of the given function, and the set formed by all the images of the element of x is called the range of the function. It's the same as in the case of relation. If there is a relation from x to y, then the set of the ordered pair, the first element of the ordered pair is known as domain, and the second pair is known as what? That is known as range. And similarly, in the case of function, if f is a function from x to y, then because every element is related to the unique element of y, so therefore the set x is known as domain, the set y is known as codomain. And here the set x is called domain and set y is called codomain. The set formed by all the images of the element of x is called the range of the function. It means the set of those element of y which are related with the element of x, that is known as what? The range of the function. It means the range is always the subset of what? Codomain of the function. Now here, and it is denoted by curly bracket fx. Clearly, range is a subset of y. The elements x and y, where x is the image of x, are denoted by the ordered pair xy, as the elements are in the relation are in the form of ordered pair, and function is also a special of type of relation. Therefore, elements x and y, where y is the image of x, are denoted by the ordered pair xy. Let us explain the definition of function with the help of example. It should be more clear. Let x be a set having element 1, 2, 3. Y is the set having element 2, 3, 4, 5, 6. Now let us suppose the image of 1 under f is 2, image of 2 is equal to 4, and image of 3 is equal to 6. Let us explain with the help of arrow diagram. Now this is the set x, this is the set y. F is a function from y, x to y. 1 is related with 2, 2 is related with 4, 3 is related with 6. Now condition of the functions are fulfilled. Every element of x is related with the unique element of y. So it is what? Therefore, this is a function from x to y. Now let us see another example. Now again I have considered the set x having element 1, 2, 3, and here the set y having same element this. Now the arrow diagram is like this. 1 is related with 2, 2 is related with 3, 3 is related with 4, and 3 is also related with 5. Now this is not a function because the uniqueness is not there. We have said in the function every element of x has a unique image in y. Here this element 3 has two images in y. Therefore the uniqueness is not there. So this arrow diagram or this function that has been defined, it is not a function. This is the function because every element of x is related with the unique element of y. So this diagram shows it is a function, and in this diagram uniqueness is not there. That this element has more than one image. 3 is related with 4 and 3 is related with 5. Therefore this arrow diagram is not a function. Let us see another example also. Now let us see case third. Let we define this arrow diagram. This is the set x, this is the set y. Now here, can you say it is a function? It is not a function because this element is not related with any element of y. Then again it is not a function. Similarly, let us case 4. Now, can you say it is a function? Again, every element of x is related with the unique element of y. So therefore it is a function. No doubt these element 2 and 3 they have same image. So again this is what? A function. Let us see the difference again. In the first case every element of x is associated with the unique element of y. So it is a function. Now here this element has more than one image, so it is not a function. Similarly, in this case, every element of x is not related with the element of y. 3 element is not related with any element, so it is not a function. Similarly, case 4. This is again a function because every element is related with the unique element of y belonging to y. Then it is again a function. No doubt these two elements have the same image, but they have only one image. F of 1 is 2, f of 2 is 3, f of 3 is 3. Every element of x has only one image in y, so it is a function. Now here let's see some important points. In a function f from x to y, number one condition is what? Each element of set x is related with a unique element of y. First condition. Second, here the two or more element of x may have same image in y. As in the case fourth, two or more element of x may have same image in y. And third is here, there may be some element of the set y which don't have any pre-image in the set x. For here this element 5 does not have any pre-image in x. Similarly, in this example, again these element 3 and 5 they don't have any pre-image in x, but it is a function. So therefore there are three conditions. The first is here, each element of set x is related with a unique element of y. Second is here, the two or more element of x may have same image in y, like this here. And third is here, there may be some element of the set y which don't have pre-image in the set x. For here these two elements 4 and 5 they are not have any pre-image in x, still it is a function. These are the three conditions that we have to follow in the case of function, then it is known as a function. Now here let me tell you one thing. Here there should be no extra element, there may be extra element. The second is here, a function may be written as y equal to fx, where x belongs to x is called the independent variable and y is called the dependent variable because the y depends upon x. As the value of x will be changed, if I am writing y equal to x here, as soon as the value of x will be changed, the value of y will also change. So therefore x is known as independent variable, where y is known as dependent variable of the function. Now here the domain of the function is the set of all real numbers for which fx is a real number or for which fx is defined or fx is meaningful. Listen it again. If f is a function from x to y, we say x is what? Domain. It is what? Codomain. But here the other thing about domain is here. Domain of the function fx is a set of all real number. Maximum the function that we consider in our question, that is a real valued function, means the function defined on the real numbers. So therefore in general the domain of the function fx is the set of all real numbers x for which fx is a real number or fx is meaningful. For example, our function is fx equal to mod of x minus 1 upon x minus 1. When we put x equal to 1 here, then the denominator goes to 0, then it is not defined. So therefore the domain of the function is what? Set of real numbers minus 1, because x cannot be equal to 1. This is the meaning of this line. Listen it again. Our functions are, all functions are defined on the set of real numbers, so they are known as real valued function. Now here the domain of the function is the set of all real numbers x for which fx is a real number or fx is defined or fx is meaningful. Again see this example. I have taken this function fx equal to modulus of x minus 1 upon x minus 1. And we know the denominator can never be 0. If x equal to 1, then denominator become equal to 0. Therefore, the domain of the function is the set of all real number except 1. So, therefore, the domain of the function is R minus element 1. So, this is what, how to find out in general the domain of the real valued function. We will delete those value of x for which fx cannot be defined. And range is the set of all the images of the element of x under f. So, therefore, the range of f equal to fx for all x belonging to x. You are just putting the value of x here in the function and getting the value of y, and the set of those value of y is known as what? The range of the function. It means the range of the function equal to fx for all x belonging to x. Now here let us see another example. Let x be a set having element 1, 2, 3, 4, 5. Y is a set having these elements. Find the function defined by fx equal to 2x plus 3. Find its domain and the range. Now the function is defined like this. Now here function is fx equal to 2x plus 3. Now we have to take the element. This is what? Independent variable. Now when we take x equal to 1, then y should be equal to 5. When x is 2, y equal to 7. When x is 3, y equal to 9. When x is 4, y is 11. When x is 5, y is 13. All these values are what? All the value of x, y can be defined. They are from this set. So therefore the function can be defined. Domain of the function is the set x itself. And range of the function is the set of f images or the values of the dependent variable. Therefore the range of the function is what? The set having elements 5, 7, 9, 11 and 13. Whereas the codomain is of the function is y itself. It is clear to you? First, x is given to be this set, y is given to be this set. Function is defined by fx equal to 2x plus 3. We have to define the function and find its domain and the range. Now we put the values of x from this set here and getting the value of x. For all values of x, there is a definite y in the set. So there the ordered pair of the function is 1, 5, 2, 7, 3, 9, 4, 11, 5, 13. For every value of x, y has a definite value in this set x. The function can be defined. Domain of the function is set itself. Range of the function is what? The set of the elements of the 5, 7, 9, 11 and 13, and all are belonging to the y. And the codomain of the function is what? The y itself. Now here let again some other points. Let f is a function from x to r. R is a set of real number. G is a function from x to r. Be two real valued function on a set x. then their sum or difference product and the quotient of two functions can be defined as a function from x to r such that the sum of two functions can be written as f plus gx equal to fx plus gx. Similarly, f minus gx can be written as fx minus gx. F into g into x can be written as f into x into gx. F upon g, this is known as quotient function. F upon gx can be written as fx upon gx, provided gx can never be 0 because the denominator cannot be 0. It is the sum of two functions. It is the difference of two functions. It is the product of two functions. It is the quotient of two functions.